All right, up on the board I've got the standard form of the equation of ellipse, and notice it's exactly the same formula, whether it's vertical or horizontal. The difference is whether A or B is bigger. A is always under X, B is always under Y. If A is bigger, X is longer, so it's horizontal. If B is bigger, then Y is longer, so it's vertical. And an ellipse has 7 specific points we want to find every time. You have the center, the 2 focal points, then you have a vertice up and right and down and left. And if you connect the 4 vertices, you create your ellipse. And try and draw it somewhat elliptical. I'm not going to expect perfection on your drawings, but you know, give me the 4 vertices in the right locations and connect those 4 dots. Don't connect like the foci with the vertices. That'll be wrong. Yes?
Can you make these ellipses on a calculator?
They can be done on a calculator, but they have to be done in pieces. There's going to be a top half and a bottom half, and they're not easily done on a calculator.
Okay.
So they're better to be done just with the standard form. So standard form, you'll notice, has a specific structure. It's a binomial squared involving x, a binomial squared involving y, equals 1, and they're both divided by numbers. And the value of b is how far you go up and down from the center to get the 2 vertical vertices. The value of A is how far you go left and right from center to get the 2 horizontal vertices. And C is the focal length, and it's going to be on the major axis being the longer axis. So if we know that A is bigger than B, then we know C is going to be left and right, and C's value is going to be A squared minus B squared. If A is less than B, in other words B is bigger, then we're going to go up and down for C, the focal points, and C squared is going to be B squared minus A squared. It's always these 2 numbers subtracted, just the big minus the small, the 2 numbers in there. So once you create standard form, everything you need to graph the ellipse is there. HK is going to be the center, just like HK was the vertex in the parabola problems. And once you know where HK is, if you know what A is, that's how far you go left and right. You know what B is, that's how far you go up and down. If you know what C is, that's how far you go left and right for horizontal or up and down on a vertical. So basically, once you know what the center is and you know what A, B, and C are, you should be able to find all 7 points and graph the ellipse very easily. Example 1 starts off in standard form, almost standard form. It looks like standard form, but there's one thing messed up about it, and I'll show you. First thing, recognize it as an ellipse. Okay, and if it already looks like this, done. Something squared over something squared over a number plus something squared over a number equals 1. It's already in standard form. It's an ellipse. All right, but again, they're both squared. They're being added together, and they have this structure. Or if it's a general form, x and y are both squared. Coefficients are different, but the same sign. So 4x squared plus 3y squared, different numbers, same sign, ellipse. All right, so x and y, same size, same sign, different coefficients. Put the equation in standard form, make the standard form that you saw on the other page. Quantity of x squared over a number plus quantity of y squared over a number equals 1. Determine if it's major axis, horizontal or vertical, which is bigger, A or B. If A is bigger, it goes horizontally. B is bigger, it goes vertically. Find the center, that's HK. Find A, B, and C. A and B are the square roots of the numbers under x and y. C is the square root of the difference of those 2 numbers. Plot the center, 4 vertices and 2 foci. So if you plot the center, you go A left, A right, B up, B down, and then either C left or right or C up and down. Connect the 4 vertices and you're done. All right, so taking a look at example 1, why is that not in standard form?
It's because it's not x, the quantity of x.
So let's do that much. So we have 4 parentheses x minus 0 squared over 25 plus y minus 0 squared over 49 equals 1. Okay, it's still not standard form. Why isn't it?
Because the bottoms are not squared, they're not the base.
Oh, no, it's not because they're not written as squares, but it doesn't. What the numbers are, what they are. That's not why. There's a specific reason why that's not standard form. So let's just real quick. I'm going to put those pages side by side and let you guys take a look. Go. How is that structure different from this structure? That's the question. How is it? Looks the same, right? There's something specifically different between that and that. You guys need a hint? Look at the tops of the fractions over there, and look at the tops of the fractions over here. Is there anything different?
There's no number in front of.
There's no numbers in front of these, right?
Yeah.
We're not allowed to have a number in front of that thing. And that makes a difference, and it matters, okay? And again, that's the key to these things, is knowing what matters. So I'm going to throw that back down there, go back to one page at a time. So what we have to deal with is that 4 on top. We don't want that 4 on top, and it's going to happen quite often. There's going to be a number in front of x squared or y squared, and that's going to happen a lot. The way you deal with that scenario is this. This fraction is being multiplied by x minus 0 squared, so we can divide by its reciprocal, and that means the same thing. So in general, if you get a number on top, it's attached to the number on the bottom in a fractional form. If you just take that fraction and reciprocate it, put it on the bottom, now you have a quantity squared on top, no number in front, over a number. And that's what we're looking for each time. And then we have y minus 0, the quantity squared, over 49, equal to 1. Okay, that's job 1. Get standard form, get good standard form. Job 2, identify it as either a vertical or a horizontal ellipse based on the size of numbers. What's bigger, 25 fourths or 49? 49 is bigger, right? If you didn't know, 25 fourths, 6.25, I believe, as a decimal. Get decimal versions so you can look at them and compare them. Okay. If b squared is bigger than a squared, then b is going to be bigger than a. So 49 is bigger, which means it's a vertical ellipse, which means my focal points are going to be going up and down. So C is going to be going up and down. That's why you want to know whether it's vertical or horizontal, to identify where C goes, because that's the only thing that varies in these problems. A always goes left and right, B always goes up and down, C depends on which direction it goes. All right, my center of this ellipse is 0, 0. I know that A is going to be the square root of this number, which is going to be 5 halves, 2.5 if you will. Decimals are fine. B is going to be the square root of this number, which will be 7. Sometimes they're pretty numbers like that. Sometimes they're decimals. Square root of 13 happens sometimes. 3.61. All right, go a couple decimal places. All right. As far as C is concerned, I know that C squared is equal to 49 minus 25 fourths. Remember that these are already squared here, so just subtract those two numbers. And 49 minus 25 fourths gives me C squared equals 96. 171 fourths maybe? Hang on. 49 minus 25 fourths comes out to 42.75.
That's what I was
Decimals
but I didn't know if you wanted to.
Yeah, decimals are fine. So C is going to be the square root of that number, which comes out to 6.538348415. Let's go 6.54. And I'm fine with decimals on this. So I know what the center is, 0, 0. I go A spaces left and right, so 1, 2.5, 1, 2.5. I go 7 spaces up and down, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And C is going up and down also. I've got to go 6.54 spaces for that. 1, 2, 3, 4, 5, 6.54. And 1, 2, 3, 4, 5, 6.54. Get my two focal points. And then I connect that with a nice elliptical shape as best we can draw it. That's pretty bad. I don't know. Here's one thing my board supplies me with that makes my life better. Got this cool magic pen. I don't want a magic pen. I want a shape drawing pen. But if I get even close to an actual shape, it'll snap right to it. You guys should invest in a pencil that does that. Anyway, so draw the ellipse somewhat well. I mean, make it curvy looking. It kind of flattens out as it gets to each vertex. I see people a lot of times they'll try and draw it and then everything's going well and then the last one they just kind of go off like that. That's not uncommon. Yeah. So again, make a good effort there. I'm not going to be grading you on your artwork, but get the vertices in the correct locations. Now, if it asks you to actually find the vertices and foci and stuff, they do want those written down ordered pairs and stuff for that. So let me just show you, what I do is I just graph everything, and then if I am asked to actually give the information, then I write it down. So my center is 0, 0. My vertices are going to be 0, 7, 0, negative 7. And then 2.5 comma 0 and negative 2.5 comma 0. And then my foci are going to be 6.54 up and down of 0, 0. So the focal points are 0 comma 6.54 and 0 comma negative 6.54. What I want you to see from that is, notice the center, what it is. We're modifying either the y-coordinate or the x-coordinate of the center to get these points. So if I'm moving left and right, the x-coordinate changes, the y-coordinate stays the same. If I'm moving up and down, the y-coordinate changes, the x-coordinate stays the same. So it's just a matter of adding and subtracting from the y-coordinate and x-coordinate from the center when you move. You add and subtract b, you add and subtract a. In this case, we add and subtract c. And the x-coordinate stays the same when we're moving up and down, y stays the same moving up and right. So if you have the center established and you know a, b, and c, it's just a matter of plus or minus this from x, plus or minus this from y, and plus or minus this, in this case, from y.